morning. This is Hemalatha, working as Assistant Professor in BVRIT Narsapur in the Department of Data Science. Welcome back to our session. Today our topic is about neural networks. We are going to discuss about this topic which is related to artificial intelligence. Why neural networks? Why the term? This topic is completely connected to our computational network, traditional computers, how our brain functions. These things has been how it has to be interrelated. Now coming to neural network, what does it mean? It means like how the interconnection will be, how our brain will function, and as basically we know, artificial intelligence itself means the mimic of human intelligence. Functioning parallelly, computationally, how the networks will function, how we are training the machines. Then we will test the data. We will be expecting some output. As it's exactly like the human activity, how we will be performing in day-to-day basis. Coming to these neural networks, we can say that it's the processing of information sharing, and we can learn from experiences, everyday experiences, and we will generate some meaningful outputs. We have some expectational outputs, but we will obviously go to the meaningful outputs. This is how the neural networks has to be. It is about. Coming to this, any computational methodology, before going to your day-to-day usage, like machine learning, deep learning, how the data has been trained, how the input has been taken, how the output will be given, and what is our expected output, all these things, basically we need to understand the biological neurons, then we have to compare it with the artificial neurons. Now, as we know, this biological neurons is made up of dendrites, the receivers, the cell body. See, comparison, it's completely comparison of how our human will function, human bodies, how our brain will function, how we are reciprocating, like these things we have to work on that. Like biological neurons, we can speak about dendrites, cell body, axons and all. When we speak about computational method, we can speak about input receivers, processing center, information transmitters and all. When some values has been given like x1, x2, x2, x3, x4 and all, it will be calculated with the weights, whatever the weights has been given to you. Through that, some mathematical functions, like we will expect some outputs based on the probability. Then we will be comparing them to the threshold values. Once it has been compared, if we get the expected output, then we'll be working on the produced outputs. Now coming to this comparison, why we are doing with the traditional computers? Because traditional computers excel at calculations, but some of the methods like feature recognition, facial recognition, these things are all problem. Really, it's a problematic. Like human brain. For example, you are in workplace. It takes time to you to recognize the person whom you are meeting. It takes time to remember the faces. Okay, and with the days passing, you will recognize like who they are, where you are into. The same way, traditional computers has been assigned with some task. But what happens? But there is a little problem in identifying the features or facial recognition or some of the changes, whatever the data has been given. For that adaptation, it takes some time. So why we need this? We need this like for the ideal application. We can say facial recognition, language translation, your Google translators. Then we can say about smart assistants, how we are adjusting based on the data process. For example, suppose you have that application of your face identification or else your finger. It takes time. It takes time to identify first day, second day, third day. After that, it will be habituated to that. Like it will measure your face, bones, like exactly to identify your face in all angles. It will be trained. Then it starts identifying the same way. The same way how we will perform, the machines also need time to accept those changes, the applications we can say. Now practical examples, we can recognize 95% of accuracy by learning, but for the training on that diverse data, it takes time. We need little slight variations definitely will be there in the facial expressions. And human brain has billions of neurons billions of neurons has been interconnected to recognize the pattern, like how a child identifies the mother immediately, then the father, then the family members. The same way, identifying the objects in nature, the same way the neural networks also replicate the same process. Some inputs will be provided, it has to be trained to recognize the patterns, then it will make some predictions, then it will give you the expected output. Now, when you work by feeding some input data, recognize the patterns, there will be some predictions in our output. Might be sometimes it might not be 100% accuracy, but definitely it will be 90 above percent, like you can expect 90, 95, 96, 97, that accuracy we can expect. And it can differentiate between like feature recognition, like you will be giving the difference between apples, oranges, the color difference, the shape difference. When we speak about animals, horse, or else cat, dog, the features of the face. So these things, that perfection will be given through some of the applications, we can say. We'll see that in the next slides. Coming to this, neuron stores some values of 0 and 1 only, which represents a specific pattern of data, and it activates based on the pattern, as it will be recognizing based on the colors. As I said, we are going with some shapes, it will recognize with the perfect features and the colors. Now, for example, why we need to understand the structure of human brain and the function of human brain. As we know, we have some, what you say, like, so see, here we have cell body, here we will be accepting the information, like whatever the information we are gathering, everything will be stored here, and the dendrites, it will be, all the dendrites will accept the things, then slowly it will be going to axon, will be carrying these things, then here the synapses will store the things, here 100% whatever you are carrying, so this 100% we may not remember. Depends on practice, again we can say. For example, your exam preparation, number of revision, depends on your hard work, right? So how much you remember? You may remember 90%, depends on the interest of your subject. You may remember 80%, you may remember 70%. It's all depend on your memory. It all depends on your how you are training your brain, how interested you are into that. So these things, exactly this biological, this structure and functioning of the neural network helps you to remember the things whatever you need. Okay. Then exactly the same thing, how the signals has been carried out, how it generates, how the messages has been transmitted, how this transmission of electric signals over longer distances, how remembering and getting this exactly how much I learned, how much I perceive, how much I convert these messages learned. Okay, here see, same way the layers. What are the layers we have in a neural network? We have input layer, output layer, hidden layers. Input layers, what you learn, okay, what you are interested to learn. The subject which you are very much interested, you will learn happily. The subject which you face difficulty, you will try to procrastinate. Okay. Now, this output layer, we can say that it produces the final information, final prediction, like exactly the features, what you remember, and these hidden layers help you to store about the shape, colors, and it depends on complexity. Again, the task, as I said, if the subject is difficult, you need lot of practice. Definitely there will be complexity in understanding the task, but practice definitely gives us perfection. Now, when we speak about artificial neural networks, or else recurrent neural networks, or else convolutional neural networks, these are all the types of neural networks. As how you remember your subjects, you will segregate it. These are all the tougher part to me, mathematical part is easier to me, theoretical part is tough to me, lab is okay to me. This is how you will be segregating. The same way, neural networks have some segregation, and these types we call it as ANN, RNN, CNN. What is ANN? What we will do here? In ANN, artificial neural network, it's like however you will be taking the inputs, as of we discussed now, it is how you will be training it, how you will be testing it, then how you will be expecting the perfection in that, Okay, this works with your artificial neural network. And the advantages with that is like it works with incomplete data as well, and definitely it will be distributed to your memory. And sometimes disadvantages, we can say that it's unexplained behavioral at times. Okay, when we speak about convolutional neural network, exactly what convolutional neural network, whatever the images has been given. Okay, as we discussed, like whatever the images has been given, like apple, oranges, as we can take the animals also, like cat and dog, feature recognition. So how it has been convoluted, exactly the images, how it has been featured, and these layers will break down into images. Then after that it will pass through the network, and each and every layers it will be passing through, it will try to detect the perfection. And we can say that medical image processing also, here in medical image processing also, what we will do, we will try to predict exactly where it is, what I want to predict, exactly which part of that organ has been diagnosed with some disease. Okay, and all these features recognition will comes under our convolutional neural network. And coming to your advantages, yes, it's high accuracy image recognition. See, when we speak about this manual testings and all, doctors will get an idea about the overall, like, okay, this person has been affected with this disease exactly in this organ. Based on that, they will start treatment. But how this helps us, how this CNN helps us? CNN helps us to predict, okay, in this organ, which part it is and what is the size of that. Okay, which stage of treatment is required for that person. Okay, then proper treatment planning can be done. For that, this convolutional neural network is very much helpful for us. Coming to these disadvantages, yes, of course, it takes a lot of large training data sets, and sometimes input, it takes a lot of time also, and large data sets also. It's a little complicated, but it will give us the accuracy. When we speak about RNN, in recurrent neural network, what we will do? There will be some sequences, it will be saving some outputs, and it will be feeding them back into the model. When it has been feeding back into the model, it helps for further learning. When we remember all the input information over time, and there will be some time series prediction also. As we know that recurrent neural network is sequences, is in order. Okay, sometimes there will be some vanishing point also. This is again disadvantage. There will be gradient problems also, like descending, and long sequences, it's difficult again. Then when we compare, okay, now it is clear that what we will do with artificial neural network, convolutional neural network, recurrent neural network. See, ANN works on tabular text data, it's like we can say that parameter sharing, and CNN works on spatial relationships like weight sharing. RNN operates on sequential data, it supports your recurrent connections and memory. Exactly when you think about, yes, this is how our brain also will function. Coming back to this example in this, how, see, many topics has been connected with any types of search, any types of what you say, like reaching, starting from the goal state, reaching the, starting from the state, reaching the goal state. You will be connected with, easiest example is traveling salesman problem. Frequently you will get, it has been connected with many types of search methods. Now, see, the problem statement to us in the TSP is about a salesman must visit a city, set of cities, return to the starting city. This is the rule of the game. Now, what is the goal? The goal is, yes, of course, shortest possible route, and exactly has to visit the city only once. Now, see, the salesman need to visit all cities, return to the starting point, and minimal travel distance. Now, a person starting from A to A, okay, A to A, exactly it will be 0, then B 0, B to B 0, then B, C to C 0. Check here, once you understand this concept, this is easy to you. Then this is 0, D to D 0, E to E also 0. Now, when you work on this in traveling salesperson problem, all the cities you visit, A to A it will be 0, B to B will be 0, C to C will be 0, D to D will be 0, E to E will be 0. 1 C. Now A to B, when I am traveling A to B here, it might be 3 kilometers, A to C, it might be 5 kilometers, A to D, it might be 6 kilometers, then A to E, it will be 7 kilometers. Okay. check the distances, check the distances travel. And one more easy method I can say that here we have taken 5 cities, okay, A, B, C, D, E. Suppose the person start from A. After traveling all the cities, he has to come back to A, and it should not be visited twice. A to B, B to C, C to D, D to E, back to A. The cities visited will be only once. Suppose, think in this way. A to C, then again he has to come back the same route, then he has to go to B. Then again he has to cross C, then he has to come to D. From the D, again he has to travel back. See, there is time complexity also, space complexity also. This is how the task will be. Sometimes will remain complicated, okay. Here, a person has to visit the cities. He has to come back to the same city, first point. Second point is, the city should not be visited twice. Third point is, again it has to calculate, the person has to calculate the shortest path travel, which is the shortest route possible. These things has to be kept in mind. Now, approach to find minimum distance. There will be permutations and combinations. Okay, how many possibilities are there, that we need to check. From A to B, B to C, C to D, D to E. This is the traversal path, how you will be traveling. And total distance travel, A to B. Then from B to C, then C to D, then D to E, E to A. So total distance travel, when you calculate these distances, what is the total distance traveling, what is the kilometer, then you travel that complex pathway also. If it has been visited, again you will be visiting, again it takes lot of time also, and we can say that traveling distance also, it will be calculated, additional points will be added on that. So for the minimum shortest route to be traveled, how you will be traveling, what is the optimal solution? Optimal solution is, I have to think about the time, I have to think about the routes. Again, I have to be very cautious that it has to be traveled twice. Okay. So this is how the approaches of the minimum distance. Now, solution approaches. When we talk about brute force approach, dynamic programming, integer linear programming, hopefully you remember last class we have discussed about brute force method. What we did there, the complete space you will be searching. Okay, then exactly where is your goal, what you need to search. First thing is you need to explore, obviously you need to explore, but you need to go with that exact location where you need to, where is your destination. Okay, now this brute force approach helps to evaluate all possible routes. As we have taken the examples of 5 cities and 24 permutations, and the time complexity is order of n to the power of 2, whereas the feasibility is small instances. You will be taking 10 cities. It's very small instances you will be taking. When you speak about dynamic programming, see, you should know the difference between this dynamic programming and the linear programming. In dynamic programming, what we'll be doing, we'll be using regression and store solutions as well as subproblems. Whereas in linear programming, you have some inequalities and it solves integer linear programming based problems, and complexity will be like depends on the problem size. The feasibility is moderate size. Now, when we speak about these approaches, we should come to the conclusion what is the best method for us. Now, when you speak about all these methods, strategies and new applications, what we are into now in the technological world, ANN is a straightforward task, whereas CNN work for the image accuracy, RNN works on the sequential data, FNN, yes, it's very simple, one-way data processing. And here today we have taken the example of traveling salesperson problem, and we emphasized on the simplest way to find the solution also. If I want to make it little complicated, how to explore, revisiting the same sites. Okay. See, say the same way, simulated annealing is also very, very important part of the topic, where you will get into the near optimal solutions, and these complexities definitely helps us to apply artificial intelligence in diverse challenges. One thing I want to say, like when you speak about simulated annealing, You can think about your BTech first year areas where you will be into the workshop, you will be working with a smithy. You will be like, you need to apply those things in the very hot iron, then you have to let it cool, then you will get the proper shape. Okay, the same thing, same application. See, finding optimal paths, yes, of course the things are tougher, but definitely after training it will perform better. So this is about applications of machines we are speaking about, and for us humans definitely it will be more easier if we are goal oriented, and what is our source, what is our destination, that we should be very clear about. Okay, and hopefully you enjoyed the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.